Welcome to the third video of the partial differential equations of module 3. In this video, I am going to explain the various possible solutions of the wave equation. So let us look into the various possible solutions of one-dimensional wave equation of the type utt is equal to c square into uxx by the method of separation of variables. Consider utt is equal to c square uxx, that is dou square u by dou t square is equal to c square into dou square u by dou x square. Let u equal to x into t be the solution of the PDE. Let us substitute this u in the solution what we have assumed. Dou square of xt divided by dt square dou t square is equal to c square into dou square of xt divided by dou x square. Since t is a function of small t, so let us take x, which is a constant outside, then x into dou square t by dou t square is equal to, the right hand side capital T is a constant because capital X is a function of small x. So that is equal to c square t into dou square d square x by dx square. Dividing by x c square t, we get 1 by c square t into d square t by dt square is equal to 1 by x into d square x by dx square. Let us say it is equal to k. That is 1 by c square t of d square t by dt square is equal to k, and 1 by x into d square x by dx square is also equal to k. Transferring the constant term to the right hand side, we get d square t by dt square is equal to c square tk, and d square x by dx square is equal to kx. Taking that to the left hand side, we get d square t by dt square minus c square of kt is equal to 0. Similarly, d square x by dx square minus kx is also equal to 0. That is, writing in the d operator form, we get d square minus c square k of t equal to 0 and d square minus k of x is equal to 0. When k is equal to 0, let us take it as a first case. Then we get d square of t equal to 0 and d square of x is equal to 0. Replacing d with the small letter m, we get the auxiliary equation m square t equal to 0 and m square x is equal to 0. Which gives us m square is equal to 0, which implies m is 0, 0. That is the second case, that is repeated real root. When the real root is repeated, we have the solution for t as t of t is equal to c1 plus c2t into e to the power of 0t, and x of x is c3 plus c4x into e to the power of 0x. That is, t of t is c1 plus c2t and x of x is c3 plus c4 of x. Therefore, combining these two, we get u is equal to c1 plus c2t into c3 plus c4x. This gives us the solution of the wave equation, that is one-dimensional wave equation in the first case when k is equal to 0. Let's see the next case. Case 2. When k is p square, that is positive, then d square minus c square p square of t is 0 and d square minus p square of x is equal to 0. By replacing d with the m, we get m square minus c square p square of t is 0 and m square minus p square of x is also 0. That is, m square minus c square p square equals to 0 or m square minus p square is equal to 0, which gives m square equals to c square p square and m square is equal to p square, or m is plus or minus cp and m is plus or minus p. So t of t will be c5 e power cpt plus c6 e power minus cpt, whereas x of x will be c7 e power px and c8 e power minus px. Hence the solution will be u equal to c5 e power cpt plus c6 e power minus cpt into c7 e power px plus c8 e power minus px. This is the second case of the solution when k is plus p square. Let's look into the next case, that is when k is minus p square, that's negative. We get d square plus c square p square of t is 0 and d square plus p square of x is also 0. Replacing d with the m, we get m square plus c square p square of t is 0 and m square plus p square of x is 0. That is, m square plus c square p square equals to 0 and m square is equal to minus p square, which gives m square is equal to minus c square p square and m square is equal to plus or minus ip. And here m is equal to plus or minus icp. Therefore, t of t will be equal to c9 cos cpt plus c10 sin cpt, whereas x of x will be c11 cos pt plus c12 sin pt. Combining the two solutions, we get u equal to c9 cos cpt plus c10 sin cpt into c11 cos pt plus c12 sin pt. This is the third case when we have k as a negative. Thank you. This is the wave equation, various solution we have discussed.